Assalamualaikum warahmatullahi taala wabarakatuh. Our group will present about our project entitled Life of Mathematician Omar Khayyam. Omar Khayyam is real name is Yad Adin Abu Fad Umar Ibn Ibrahim Al-Hayami An-Nishapuri. He's born in Nishapur, Persia on 18 May 1048. His father's name is Ibrahim Hayami and he's believed to be involved in tent making because Khayyam is mean tent maker. His expertise in mathematics, astronomy, philosophy, medicine, and poetry. He died on 4 December 1131 when he is 83 years old in Nishapur, also Persia. His body was buried in the famous Khayyam Garden at Imam Zadeh Makhruk Mausoleum. In his early youth, Omar Khayyam studied the science and mastered all branches of knowledge in his native town. Then he moved to Balkh and began rigorous studies under an eminent Persian scholar which is Sheikh Muhammad Mansuli. Shortly after that, he became student under Imam Muwafiq Nishapuri, an eminent scholar who had a high academic position in the region. In 1070, he decided to transit his education to the second largest city in Uzbekistan, which is Samarkand. At the Samarkand, he wrote his famous algebra treatise that influenced English mathematician John Wallis in his 20s. Then Omar Khayyam completes groundbreaking mathematical and astronomical work all before the age of 25. After that, he sought education in the cities of Bukhara, the largest cities in Uzbekistan. He spent time teaching geometry and other forms of mathematics to the students who travelled from all over the region to study under his wisdom. He was also a court advisor for Seljuk Shah. Then he was permitted to return to his birthplace Nishapur and continued his groundbreaking work in the field of astronomy, medicine and mathematics. Omar Khayyam died in his birthplace at age 83 when he was working as a professor.
Turning our attention now to Omar Khayyam's contributions to mathematics. Based on our finding, there are four major contributions of Khayyam to mathematics. The first one is the parallel postulates. The first mathematician who introduced these postulates was Euclid, which is the fifth of Euclid's 5 postulates in his book, The Element. The postulate was, if a transversal falls on two lines in such a way that the interior angles on one side of the transversal are less than 2 right angles, then the lines meet on the side which the angles are less than 2 right angles. As an illustration, we focus on the two figures below. When each angle is 90 degrees, the lines are parallel. If one or both of the angles is less than 90 degrees, the lines will meet. Since the time the Elements was first published, mathematicians has been trying to use Euclid's first 4 postulates to prove the parallel postulate. They were doomed to fail. Omar Khayyam's attempt was interesting. Consider a straight line AB. Then consider two equal lines that are perpendicular to AB and seize 3 possible arrangements which can produce 4-sided figures. He refutes that the possibility that angles C and D can be anything other than right angles. In the image shown, only the central option is possible. So he believes he has proven the parallel postulate. In fact, he has not done so. All he has done is stated it in a different way. What is interesting to historians of mathematics is that in Khayyam's ideas, they can see the first glimmers of non-Euclidean geometry. His second contribution is the binomial theorem. In his algebra book, Khayyam refers to another work of his called Problems of Arithmetic, which is now lost. In the lost work, Khayyam discussed the Pascal triangle, but he was not the first to do so since Al-Khariji discussed the Pascal triangle before him. In his algebra, Khayyam writes that method for calculating square and cube roots come from India, and that he has extended them to the determination of roots of any order. Even more interestingly, he says that he has demonstrated the validity of his method using proofs that are purely arithmetic, founded on the arithmetic of the elements. If both of these statements are true, then it is hard to avoid the conclusion that Khayyam had within his power the binomial theorem, which would be the earliest appearance of the important result in medieval Islam. In fact, scholars can be fairly sure that Khayyam used a method of finding the end root based on the binomial expansion, and therefore on the binomial coefficient.
We're moving on to the third point of Umar Khayyam's contribution to mathematics, the real number concept. So it started off by mid-4th century before Christ, when Euclid dealt with the theory of proportions, which means two varying quantities are said to be in relation of proportionality and the compounding of ratios. And he also produced the theory of equal ratio, which has been called golden ratio. Then Umar Khayyam discussed the relationship between the concept of ratio and the concept of number and explicitly raises various theoretical difficulties. He also contributed to the theoretical study of the concept of irrational numbers, and he redefined the concept of number by the use of a continuous fraction as the means of expressing a ratio. We're moving on to the fourth contribution, the cubic equation. So it started off by the ancient Greek era, where they has two tools, the straight edge to draw straight lines and the compass to draw the circumference of the circle. Khayyam conjectured correctly that it is not possible to solve cubic equations using the traditional ancient Greek geometrical tools. So by the age 22, on the year 1070, Khayyam published first paper titled Treatise on Demonstration of Problems of Algebra and Balancing. In it, he stated cubic equations can have more than one solution. Second, the equations which involve the inverse of the unknown. And the third is how the interaction of conic sections such as parabolas and circles can be utilized to yield geometric solution of cubic solutions. Archimedes has been considered this years before, but focusing on the specific problem, and Khayyam considered the problem in a more general mathematical way, and he was first to conceive a general theory of cubic equation and the first to geometrically solve every type of cubic equation. So this picture over here featured a parabola of equation. While Khayyam actually did not possess knowledge of negative numbers at the time, he could only work with positive real solution. He ended up solving the mathematical problem by intersecting a circle with a hyperbola. Efficiently, Khayyam's work is an effort to unify algebra and geometry. The German mathematician Franz Wuppke by 1851, who offered translation of Khayyam's algebra into French, praised him for his power of generalization and his rigorously systematic procedure.
Okay, next we look at Omar Khayyam's contribution to astronomy. It started when Sultan Malik Shah invited him to Isfahan in 1073 to undertake the astronomical observation necessary for the reform of the calendar. Then Omar Khayyam started travel to Isfahan in 1074. To accomplish the mission, the observatory has been set up in Isfahan, and Omar Khayyam lead the scientists. Omar Khayyam also led work on compiling astronomical table titled Zili Malikashi. Then, in 1079, he produced a new Jalali calendar, which is the accurate solar calendar. Then, Malik Shah announced 1079 as the Jalalian era. He also founded the measurement of the length of the year as 365.24 to 19858156 days, which is the result is outstandingly accurate. In 1092, Omar Khayyam's astronomical observation ended due to political event. This is an example how Omar Khayyam made a Jalali calendar by making 8 of year 33 years leap years. Okay, next we go to application of Omar Khayyam theory in this day. This is an example of the application of Omar Khayyam theory. The picture shows the geometrical mean in the north dome of Friday Mosque of Isfahan. Lastly, we look to the theory of triangle and geometry. According to Azdurul in his article, the geometrical scheme of the north dome appears to be generated wholly from Omar Khayyam's triangle. And geometry theory has a great significance to the history of Islamic era. And next, we go to ratio theory. Omar Khayyam used the ratio in his work of music theory. He used his ratio theory to deal with musical interval. Furthermore, algebraic solution. By using algebraic solution, it used to solve the problem of the determination of the quantities of gold and silver in alloy by weighing in the air and water. This problem has been solved by Khayyam's pupil named Abdul Rahman Al-Khazini. Okay, last but not least, Omar Khayyam also deals with deals with the proof of the Indian method of extraction of the square and cube roots. This method then extended and became the base of quadratic square, quadratic cube, and others.
Okay, hi everyone. So I'm gonna continue about how does his works influence in mathematics development. So first of all, Omar Khayyam is undoubtedly among the most groundbreaking in the history of mathematics. His mathematically related works include astonishing contributions to the calendar and flabbergasting solutions to cubic equations that prove essential to the future development of mathematics. Next, while in Samarkand, Khayyam wrote his groundbreaking treatise on demonstration of problems of algebra. In this work, he verbalized the foundations of algebra and brought forth a fascinating demonstration of solutions to cubic equations. He is known as the first mathematician to present a solution to cubic equations. His computations were written in prose, which greatly simplified things as his work was spread throughout Europe and Asia. Omar Khayyam's progress with the cubic equations facilitated solutions with equations up to a degree of 5, as well as progress in the field of analytical geometry by René Descartes. As a conclusion, we know from this project that a mathematician is someone who uses their work and extensive knowledge of mathematics, typically to solve mathematical problems. During the Middle Ages, science and mathematics in the Islamic world follow different models and modes of funding varied, mainly based on scholars. Omar Khayyam is one of the famed Islamic mathematicians. His works related to mathematics include astonishing contributions to the calendar and flabbergasting solutions to cubic equations that have proved essential to mathematics' future development. And lastly, Khayyam's mathematical abilities have proven mind-boggling to historians and mathematicians, as his ability to extract roots surprisingly and effectively sprouted theories about his true mathematical skills.
Okay, that's all from us. Thank you for listening.